Hello everyone, welcome back to our channel, and today we have to simplify this expression. We call it expression because it's not equal to any term, it's just standing on its own. So what do we do to expression? We simplify them. We rather write them, break them down mathematically to the simplest and the barest minimum. We are going to do that together and simplify it. Okay, so what do we do first of all? And I will recommend that we are very conversant with the laws of indices, because if you look at the equation very carefully, you are seeing raised to power minus 1. What does that mean? And you can see each of the terms raised to power is raised to a power, certain power, in some cases even negative power. So how do we handle such challenge? If A is raised to power minus 1, like this case, assuming this is the A and it's raised to power minus 1, the A should become 1 over A. You see this? So we're going to turn our expression to 1 over A. So if A, for example, over B is raised to power minus n, and the n is the power is on the negative, the B becomes the numerator, which is previously denominator, over A, and it's still raised to power n. But now the negative is no longer there, because you have interchanged their position. Look at this. If we remember this and we agree on this, then we can handle the equation expression very effectively. And also, if you can remember, if A as a base is raised to m over n, what should A become? A will become the nth root of A to the power m. Look at this. The denominator is what we use to form the root, while the numerator becomes the only power that is left. You must remember this. If you can remember this, we handle this. You know what? Why are we bringing in this? Because we are having such cases here, where we have a term that is raised to 2 power that are dividing each other. Look at this here. Even in this case, it's negative. You see 1 over 3. So we employ this for the first one and this for each of them. So we start by saying solution. We want to say 125 raised to power minus 2 over 3 multiply 225 raised to power 3 over 2 all over 216 raised to power 1 over 3. See? At this time, you can say raised to power 1, because we have removed the negative sign. Look at it here. We have removed the negative sign. We have employed this, and the negative sign is off. And so we want to come and use this now. So the cube root of 125, look at this, raised to power what? Minus 2. Don't forget it. There's minus there. Minus 2. Multiply the square root of 225. Raised to power what? 3 all over the cube root of 216 raised to power 1. So we have successfully expressed our expression using this law. Now it becomes easy. So what is it saying here? Let me interpret this to you. We are saying that what is that number that we multiply 2 times? You know, there's 2 here. But we don't usually write it because we know this is the sign for the square root, and square is 2. Alright, you see? So what number are we going to multiply 2 times? Think of a number we multiply 2 times to give us 225. And that number is 15. If you multiply 15 2 times, the answer you will get is 225. And here, there's a certain number when we multiply 3 times, it will give us 125, and that is 5. 5 times 5, 25. 5 times 25 is 125. So we're going to write 5 raised to power minus 2. Don't forget that minus 2. And here, a number we need to multiply 3 times to give us 216. That number is 6. You can check it out. That's 6. You see? Don't forget this raised to power 3. Well, we did that before. If you forget it, you get the wrong answer. So now let's solve this. It's getting simpler. You can see. So this becomes, okay, yeah, we can transpose this to be a minus 1 or minus n becomes 1 over a raised to power n, and here becomes 1 over 5 raised to power 2 times 15 times 15 times 15, 3 places become 3375. You can confirm this. All over 6. If we make this over 1 and 5 raised to the power 2, that is 25. That's 25. 1 over 25 times 3375 all over 6. Here can cancel out. If you do this, if this is over 1, okay, we can use 5. What can go? What 5 can go? 5 into 25, we will have 5. 5 into 33, we have 6. Remaining 3. Carry the 3 put here. 5 into 37, we have 7. Yes, we have 7. Is left with 2. 5 into 25, that is 5. Fine. So 5 can go again. Yes. 5 into 5, 1. 5 into 6, we have 1. Left with 1. Put it on the front of the 17, becomes 17. 5 into 17, 3, and it's 15. What is left? 2. 5 into 25 is 5. So our final answer is 1 times 135 all over 6. Continue from here. 1 times 135 is 135 all over 6. Is what it is. You see how it becomes? We have been able to simplify what we're given with the laws of indices. Okay, let's go. So we go by division. 6 divided by 6 becomes 1. 6 into 13, we have 2. Yes, 2. And to be left with 1, we have 15 there. What can go into 15? 6 can go into 15. What do we have again? 2. And what is left is 3. 6 cannot go into 3. So what do? We put a point here and add 0. You see? So when 6 enter divide 30, that is 5. 5 times. 5 times. So that's 0.5. 5 times. And this our final answer therefore becomes 2.5. 2.5, the simplest form that we can simplify that expression to be. Or we can, it's also equals to 2 over 1 over 2. If you so wish to put in this form, it's still the same answer. And this is the end of the simplification of this complex number. Eventually we arrive at 22.5 or 22 1 over 2. 22 and a half. So far, if you derive any value, if you are not subscribed to this channel, please do.